The morning air at the Kummersdorf proving grounds carried the sharp bite of early August, 1944. Klaus Reinhardt stood at the firing line, his hands wrapped around a rifle that weighed nearly 10 pounds heavier than he'd expected for what intelligence reports claimed was the standard American infantry weapon. The wooden stock felt solid against his shoulder, the metal surprisingly warm despite the cool morning. He'd spent 3 years at this facility south of Berlin, examining captured weapons from every theatre of the war. French levels with their obsolete tube magazines, British Lee Enfields with their smooth bolt action, Soviet Mosin Nagants, crude but effective. Each weapon had revealed something about the nation that produced it, their industrial priorities, their tactical assumptions, their understanding of modern warfare. But this American rifle, recovered from a dead paratrooper near Carentan just weeks earlier, would tell Klaus Reinhardt a story he wasn't prepared to hear, a story about the gap between what Germany believed about American military capability and what actually existed on the battlefields of Europe. He chambered the first round, feeling the bolt slide forward with mechanical precision. The N-block clip 8 rounds held in a stamped steel guide sat flush in the receiver, loaded from above in a way that struck Klaus as both elegant and strange. No detachable magazine to lose in combat. No stripper clips requiring manual loading of individual rounds into an internal magazine. Just insert the clip, press it down until it locked, and the rifle was ready. He raised the weapon, acquired the first target downrange, a standard silhouette at 100 meters, and squeezed the trigger. The rifle fired. The recoil pushed against his shoulder, manageable and controlled. But before Klaus could fully process that first shot, his finger had already returned to the trigger. He fired again, and again. The rifle didn't require him to work a bolt, to break his sight picture, to manually cycle the action between shots. It simply fired, ejected the spent brass, chambered a new round, and waited for his next trigger pull. 8 shots erupted from the barrel in a continuous rhythm that Klaus's engineering mind initially rejected as impossible for a standard infantry rifle. The en-bloc clip ejected with a distinctive metallic ping, a sound that would become legendary among American troops, though Klaus didn't know that yet. The rifle was empty, its action locked open, ready for immediate reload. Klaus lowered the weapon slowly. His hands remained steady, but his mind raced through calculations that refused to balance. This wasn't a machine gun. This wasn't a specialized weapon for elite assault troops or designated marksmen. According to the intelligence documents accompanying the rifle, according to the markings stamped into its receiver, according to everything they'd been told about American small arms, the M1 rifle, the standard issue weapon carried by every single American infantryman in Europe and the Pacific, every soldier, every rifleman, every private fresh from basic training carried a semi-automatic rifle capable of firing 8 rounds as fast as a trained finger could pull the trigger. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Klaus Reinhardt had joined the Heereswaffenamt, the Army Weapons Agency, in the spring of 1941 with the confidence of a man who understood his place in the natural order of military technology. He studied mechanical engineering at the Technical University of Berlin, one of Europe's premier technical institutions, graduating with highest honors in 1938. His thesis had examined bolt-action rifle mechanisms with the meticulous attention to detail that characterized German engineering education. He compared the German Karabiner 98K with its international counterparts, the British Lee Enfield, the American Springfield, the Soviet Mosin Nagant. The Kar 98K had emerged from his analysis as a masterpiece of precision engineering, reliable across temperature extremes, accurate to ranges exceeding 500 meters, manufactured to tolerances so exact that parts from rifles produced years apart could be swapped without fitting or adjustment. It was the rifle that had armed the Wehrmacht through its spectacular victories across Poland in 1939, through the conquest of France in 1940, through the vast expanses of the Soviet Union beginning in 1941. The Kar 98K represented everything Klaus had been taught to believe about German military superiority. It wasn't just a weapon, it was a statement about national character, about the triumph of quality over quantity, about the value of skilled craftsmanship and engineering, excellence. The proving grounds at Kummersdorf stretched across several square kilometers of cleared land south of Berlin, a sprawling complex of test ranges, workshops, laboratories, and administrative buildings that had served as Germany's primary weapons testing facility since the First World War. By 1944, as the strategic situation deteriorated on multiple fronts, Kummersdorf had become even more critical to the war effort. Every captured weapon passed through facilities like this one. Every new German prototype underwent evaluation here. every technical assessment, every performance report, every recommendation that Klaus and his colleagues produced flowed upward through the military bureaucracy to influence production decisions worth millions of Reichsmarks and tactical doctrines that shaped how German forces fought. When Klaus evaluated a weapon, he wasn't simply satisfying academic curiosity or adding data points to some abstract technical database. He was providing intelligence that could shift the balance of battles yet to be fought. If a captured Soviet anti-tank rifle proved effective beyond expected parameters, German armor designers needed to know. If a British aircraft gun demonstrated superior reliability in cold weather conditions, Luftwaffe planners needed that information. The work carried weight, carried consequence, carried the knowledge that his assessments might mean the difference between German soldiers living or dying in combat. The captured American rifle, officially designated as U.S. rifle, caliber .30 M1 in the translated technical manual, but referred to simply as the Garand by American troops, after its designer John Garand had arrived at Kummersdorf in late July 1944. It came as part of a batch of equipment recovered from the Normandy battlefields, shipped east for evaluation, along with American uniforms, ration kits, medical supplies, and other materiel that might reveal something useful about enemy capabilities. The rifle had been cleaned and inspected by the recovery team, but bore the marks of combat use: scratches on the wooden stock, wear on the metal surfaces where a soldier's hands had gripped it repeatedly, a small dent in the butt plate from some impact Klaus could only imagine. Klaus had read the preliminary assessment reports with skeptical interest. The weapon was supposedly semi-automatic, firing one round per trigger pull without requiring manual operation of a bolt or other mechanical cycling system. Such rifles existed, certainly. They weren't theoretical or experimental. The Germans themselves had fielded semi-automatic designs. The Gewehr 41 had entered limited production beginning in 1941, though persistent mechanical problems and manufacturing complexity had prevented widespread deployment. The improved Gewehr 43, introduced in 1943, addressed some of these issues, but remained expensive to produce, and was issued primarily to designated marksmen and specialized units. This reflected what Klaus understood to be the fundamental economic and tactical reality of semi-automatic rifles. They were sophisticated weapons, appropriate for soldiers who needed enhanced firepower in specific roles, designated marksmen who might need quick follow-up shots, assault troops storming fortified positions, reconnaissance units operating independently. But the complexity of their gas-operated or recoil-operated mechanisms, the precision manufacturing required for reliable function, the maintenance challenges in field conditions, the cost per unit, all of these factors made semi-automatic rifles unsuitable for mass distribution to standard infantry. That wasn't ideology or prejudice. It was simple industrial mathematics. The German military's doctrinal foundation, refined through years of warfare across multiple theaters, centered on the bolt-action rifle as the infantry's primary individual weapon. A standard Wehrmacht infantry squad, a Gruppe, consisted of 9 men organized around a clear firepower hierarchy. One soldier operated the MG-34 or MG-42 machine gun, weapons capable of sustained fire rates approaching 1,000 rounds per minute. This was the squad's primary source of firepower, the weapon around which tactical maneuvers were organized. The other 8 soldiers carried Kar 98K bolt-action rifles. Their role was to provide covering fire, engage point targets with accurate aimed shots, and maneuver under the protection of their machine gunners' suppressive fire. This system had proven devastatingly effective. The high rate of fire from the machine gun could suppress enemy positions or cover an advance. The rifleman could engage targets individually with the precision that bolt-action rifles provided. The combination worked. It had worked in Poland, in France, in the Balkans, across vast distances in the Soviet Union. German tactical doctrine didn't require every soldier to have a semi-automatic rifle because the machine gun provided suppressive firepower while riflemen delivered accuracy. It was efficient, it was proven, and it reflected realistic assessments of what industrial capacity could sustain across millions of soldiers. Klaus carried these assumptions with him as he prepared for the formal testing program. The M1 Garand would be evaluated according to standard protocols developed over years of captured weapons assessment. Accuracy testing at multiple ranges, reliability testing under various conditions, rate of fire measurements, ease of maintenance evaluation, durability testing through sustained firing programs. Every captured weapon received the same rigorous analysis, regardless of origin or the preconceptions evaluators might hold. He'd requisitioned several thousand rounds of captured .3006 Springfield ammunition, the M1 standard cartridge, identical to what American forces used in their machine guns and the older Springfield bolt-action rifles that some troops still carried. The ammunition itself had impressed Klaus during his initial inspection. The brass cases were uniform, manufactured to consistent specifications that spoke to industrial quality control. The projectiles were precisely seated. The primers showed no variations that might indicate rushed wartime production. Even American ammunition, basic consumable supplies produced in quantities measured in billions of rounds, reflected manufacturing standards that exceeded what Klaus had seen in comparable German production. But he'd attributed this to American industrial excess, the wastefulness of a nation with seemingly unlimited resources. Of course, they could maintain high standards for ammunition when their factories weren't being bombed, when their industrial workforce wasn't being drafted into emergency military service, when they had access to raw materials from across the globe. It didn't necessarily mean anything significant, or so Klaus had told himself. On the morning of August 3rd, 1944, Klaus set up his first formal test sequence. The Kummersdorf rifle range stretched across open ground, with target frames positioned at 50-meter intervals out to 500 meters. He'd prepared data sheets for recording every measurement, every observation, every detail that might prove relevant to the final assessment report. 3 other engineers would observe the testing, taking their own notes, providing independent verification of results. This was standard procedure. Individual bias or error needed to be controlled through multiple observers and documented methodology. Klaus loaded the first en-bloc clip with the careful attention of an engineer examining an unfamiliar mechanism. The clip held 8 rounds in a precise vertical stack, retained by stamped steel flanges that gripped the cartridge rims. The entire assembly clip and cartridges together loaded into the rifle's action from above, a design that struck Klaus as both innovative and slightly awkward. His hands were accustomed to stripper clips that fed cartridges into an internal magazine, then were discarded. The M1's en-bloc clip remained in the rifle as rounds were fired, then ejected automatically when the last round was chambered. It was clever engineering, eliminating one manual step in the reloading process. Klaus appreciated the logic even as he found it strange. He inserted the loaded clip into the receiver, feeling it click into place as the bolt moved forward. The mechanism felt solid, positive, with none of the looseness or play that might indicate poor manufacturing tolerances. He worked the charging handle, chambering the first round, then settled into a standing firing position. 100 meters, a standard silhouette target. He aligned the aperture rear sight with the front post sight, centered the sight picture on the target's chest area, controlled his breathing, and pressed the trigger with steady, increasing pressure until the rifle fired. The report was sharp, but not unpleasant. Recoil pushed straight back into his shoulder, less than the Kar 98K despite the M1's comparable cartridge. The rifle's weight and gas-operated system absorbed much of the recoil impulse. Klaus's sight picture recovered quickly. He found himself looking through the sights at the same target, the rifle ready to fire again without any action on his part beyond pulling the trigger. He fired a second shot, then a third. Each shot felt identical, same trigger pull weight, same recoil impulse, same mechanical cycle. The rifle simply worked, with a smoothness that reminded Klaus more of a well-tuned machine than a combat weapon expected to function under battlefield stress. He fired the remaining rounds at a measured pace, one shot approximately every 3 seconds. This was how a trained rifleman might engage targets, with aimed fire not rushing, taking time to acquire proper sight alignment, focusing on accuracy over speed. 8 rounds total. The last shot left the chamber empty, the bolt locking back on the magazine follower. The en-bloc clip ejected automatically, falling to the ground with that distinctive metallic ping. Klaus lowered the rifle, his mind already processing initial impressions. The M1 had performed flawlessly. Accuracy appeared excellent. He'd need to examine the target for precise shot placement, but his sight picture had been consistent throughout. The semi-automatic action cycled smoothly, with no failures to feed or extract. Recoil was manageable even for sustained firing. The trigger, while not as refined as a precision target rifle, was consistent and predictable. By any objective measure, this was a well-designed, well-manufactured military rifle. Klaus made careful notes on his datasheet, recording observations without interpretation. The data would speak for itself once enough had been collected, but something nagged at Klaus's engineer's intuition. The rifle was too good. Not in its individual components or mechanisms, those made sense, represented sound engineering choices. But the totality of it, the completeness of the design, the quality of manufacture, all in a weapon supposedly issued to every American infantryman that didn't align with what Klaus understood about military production priorities. Semi-automatic rifles were complex. They were expensive. They required skilled labor to manufacture and maintain. You didn't equip ordinary infantry with such weapons. You couldn't. The industrial resources required would be prohibitive. Unless, Klaus thought, the industrial resources weren't prohibitive. Unless American manufacturing capacity was so vast that what seemed impossible by German standards was merely routine for American factories. But that couldn't be right. That suggested an industrial disparity so enormous that Germany's entire strategic calculus would be flawed. Surely intelligence assessments would have identified such a gap. Surely German leadership would have adjusted their strategies accordingly. The idea was too disturbing to pursue, so Klaus set it aside and continued with the testing protocol. He loaded another on-block clip. This time, he would conduct the rapid-fire test standard procedure for all captured weapons. The goal was to determine the maximum sustainable rate of fire under combat conditions. Not wild, unaimed shooting, but rapid engagement of targets while maintaining reasonable accuracy. This test revealed how a weapon would perform when a soldier faced immediate threats, when speed mattered as much as precision, when the mechanical capabilities of the weapon, rather than the shooter's careful technique, determined effectiveness. Klaus acquired the target, focused on his sight picture, and fired as quickly as he could while maintaining basic accuracy standards. His finger worked the trigger in rapid succession, each pull immediately followed by the next as soon as the rifle completed its firing cycle. 8 rounds left the barrel in approximately 6 seconds. The clip ejected. The action locked open. Klaus stood perfectly still, the rifle warm in his hands, his engineering mind churning through implications that he didn't want to accept but couldn't deny. 6 seconds. 8 rounds. That was faster than he could operate the Kar-98K, even if he abandoned all pretense of aimed fire and simply worked the bolt as rapidly as his hands could move. A trained German rifleman, under ideal range conditions with no stress or enemy fire, might achieve 15 to 20 aimed shots per minute with the Kar-98K if he was skilled and experienced. Klaus had just fired 8 aimed shots in 6 seconds with the M1 Garand, a theoretical rate of 80 rounds per minute, and he wasn't particularly skilled with this weapon. He'd fired perhaps 20 rounds total. An American soldier, trained from basic training on this rifle, familiar with its weight and balance and characteristics as intimately as Klaus knew his own Kar-98K, conditioned to its operation until loading and firing became as instinctive as breathing. What rate of fire could such a soldier achieve and sustain? Klaus loaded another clip, then another, and another. He varied his firing rhythms, testing the weapon's limits and his own ability to operate it effectively. He fired from different positions, standing, kneeling, prone. He deliberately induced malfunctions by short-stroking the trigger, failing to allow the action to complete its full cycle. The rifle forgave his errors, simply waiting for proper operation before continuing. He tried to generate failures, to find the weak points that every weapon possessed. The M1 continued functioning. After 200 rounds, Klaus field stripped the weapon according to the procedures outlined in the translated American technical manual. The disassembly was straightforward, requiring no tools beyond the rifle itself. A small pin released the trigger group. The bolt and operating rod assembly came free as a single unit. The gas cylinder unscrewed by hand. The entire rifle could be reduced to its major components in less than 2 minutes, cleaned and reassembled without special training or gunsmith expertise. This was soldier-proof engineering design that acknowledged the realities of field maintenance by minimizing complexity and eliminating tight tolerances that might require skilled adjustment. Klaus examined each component carefully. The gas system was brilliantly simple, a piston driven by propellant gas tapped from a port in the barrel, transmitting energy through an operating rod to a rotating bolt that locked securely into the receiver through locking lugs. It was robust, over-engineered if anything, with enough built-in tolerance to function reliably even when fouled with carbon residue or inadequately lubricated. The bolt itself was machined from solid steel, with surfaces hardened to resist wear. The extractor was spring-loaded, maintaining constant tension on the cartridge rim. Every design choice spoke to reliability over elegance, function over refinement. German engineering philosophy typically pursued optimization, designing mechanisms to exact tolerances, minimizing weight and material usage, creating systems that performed at the theoretical limits of their components. The M1 Garand reflected a different philosophy over building systems to ensure they functioned under the worst conditions, accepting extra weight and material cost in exchange for absolute reliability, designing for the average soldier rather than the expert user. Klaus understood the logic intellectually, but seeing it embodied in a standard infantry rifle, issued to millions of ordinary soldiers, forced him to confront assumptions he'd held about American military capability. That evening, sitting in his office at Kummersdorf with the day's data sheets spread across his desk, Klaus wrote a single sentence in his personal notebook. If this is truly their standard infantry rifle, we have fundamentally misunderstood American military doctrine. He underlined the sentence twice. Then he sat staring at it, smoking one cigarette after another, trying to work through implications that cascaded further with each thought. The next morning, Klaus expanded his testing program. He recruited 3 other engineers from the facility men with varying levels of marksmanship, training, and combat experience. He wanted to determine whether the M1's performance was dependent on user skill or inherent to the weapon's design. If only experienced shooters could extract maximum effectiveness from the rifle, then perhaps it remained a specialized weapon despite American claims of universal issue. But if even moderately trained soldiers could achieve impressive results, then the M1 represented a true force multiplier that elevated every rifleman's capability. The results were consistent across all 4 testers. The most experienced marksman among them, a former Wehrmacht infantry sergeant who'd served on the Eastern Front before being reassigned to Kummersdorf after recovering from wounds, achieved firing rates exceeding 100 aimed rounds per minute in short bursts. Even the least experienced engineer, a young man who'd never served in combat and had minimal rifle training, could maintain 50 to 60 aimed rounds per minute. Every tester, regardless of skill level, vastly exceeded what they could achieve with the Kar-98K. Klaus documented everything methodically: firing rates at various ranges, accuracy measurements, time required for reloading, ease of maintenance, reliability under different conditions. They tested the rifle after being soaked with water, after being exposed to dust, after being deliberately fouled by firing hundreds of rounds, without cleaning. The M1 continued functioning. When they finally induced a malfunction by completely disabling the gas system, the rifle could still be operated manually by working the charging handle between shots, essentially converting it to a heavy bolt-action rifle that still functioned as a weapon. Klaus requested additional captured M1 rifles for comparative testing. He wanted to determine whether the rifle he'd been evaluating represented exceptional manufacturing quality or typical American production standards. Over the next 2 weeks, 5 more Garands arrived from various sectors of the Western Front, rifles recovered from different American divisions, manufactured at different times in different facilities. Each rifle received the same battery of tests Klaus had conducted on the first weapon. What he discovered disturbed him more profoundly than any individual rifle's performance. Every M1 was essentially identical, not similar in the way that weapons from the same production run might be similar, identical. Parts from rifles manufactured months or years apart could be interchanged without any fitting or adjustment. The barrels were machined to identical specifications. The gas systems functioned identically. Even wear patterns appeared similar, suggesting that American soldiers used and maintained their rifles according to standardized procedures that were actually followed in the field. This level of interchangeability represented manufacturing capability that went beyond simply producing weapons in large quantities. It required industrial systems that could maintain consistent tolerances across multiple factories, across extended production runs measured in years, across millions of individual rifles. The Germans had achieved similar interchangeability with the Kar-98K, but that was a relatively simple bolt-action design manufactured in established facilities using traditional gunsmithing techniques refined over decades. The M1 was vastly more complex, yet American factories had achieved the same standardization. Klaus began compiling his formal assessment report in late August 1944. This was the critical phase of his work, translating technical observations into strategic intelligence that could inform military leadership. He wrote carefully, aware that his assessment might be dismissed as defeatist or pessimistic if he wasn't cautious in his framing. German military culture valued aggressive confidence, offensive spirit, the belief that willpower and tactical excellence could overcome material disadvantages. Reports suggesting fundamental enemy superiority required ironclad evidence and diplomatic phrasing that presented facts without appearing to advocate for strategic changes that weren't within an engineer's authority to recommend. He started with pure technical specifications, the objective data that couldn't be disputed. The M1 Garand fired the .30-06 Springfield cartridge, a powerful round comparable in performance to the German 7.92 by 57 mm Mauser cartridge. Muzzle velocity was approximately 2,800 feet per second. The effective range exceeded 400 meters. The rifle weighed 9.5 pounds when loaded with a full 8-round en bloc clip heavier than the Kar-98K's 8.6 pounds. but not prohibitively so given the benefits of semi-automatic operation. Magazine capacity was fixed at 8 rounds via the on-block clip system. Rate of fire, as documented through extensive testing, 40 to 50 aimed rounds per minute for an average soldier, potentially reaching 80 to 100 rounds per minute for experienced troops in short bursts. Then Klaus began the section that made his hands hesitate over the typewriter keys. He titled it Operational Implications and Strategic Assessment, dry bureaucratic language that might make the content more palatable to readers conditioned to discount pessimistic analyses. The M1 rifle represents a fundamental shift in infantry firepower distribution, he typed carefully. Previous semi-automatic rifle designs, including our own Gewehr 41 and the improved Gewehr 43, have been hindered by mechanical complexity, manufacturing cost, and reliability concerns that necessarily limit their deployment to specialized roles. The American M1 overcomes these limitations through exceptional design simplicity and manufacturing excellence that enables mass production while maintaining consistent quality. It is a weapon designed not for selected marksmen or assault troops, but for universal issues to ordinary infantry. Klaus paused, lighting a cigarette and drawing deeply while considering his next paragraph. The words he was about to write could be interpreted as defeatism, as undermining confidence in German military capability. But they were true, supported by extensive testing data, and military leadership needed to understand what German forces faced on the battlefield. If intelligence estimates are correct, that the United States has equipped its entire infantry force with this weapon system, he continued typing, we must fundamentally reconsider our tactical assumptions regarding American rifle platoons and their combat effectiveness. A German infantry squad contains 9 men, 8 riflemen, armed with Kar-98K bolt-action rifles, and 1 machine gunner with an MG-34 or MG-42. In this organization, the riflemen provide supporting fire and maneuver capability, while the machine gun delivers primary suppressive firepower. An American rifle squad, if equipped entirely with M1 Garands, possesses aggregate firepower that approaches or potentially exceeds that of a German squad, despite lacking a comparable machine gun in the designated machine gunner role. He did the mathematics carefully, showing his calculations. A German infantry squad under ideal circumstances might deliver 120 to 150 aimed rifle shots per minute from its 8 Kar-98K equipped soldiers, plus 800 to 900 rounds per minute from its machine gun, though sustained fire at that rate was impossible due to barrel heating, ammunition supply constraints, and the need for controlled burst firing. An American squad with 8 riflemen armed with M1 Garands, each soldier achieving even a conservative 40 rounds per minute, could deliver 320 aimed rifle shots per minute. Add in their Browning automatic rifle, essentially a light machine gun issued at the squad level, and the firepower differential became significant. But raw numbers didn't capture the full tactical implications. Klaus understood that combat effectiveness wasn't purely mathematical. The psychological impact of sustained rapid fire affected both the soldiers delivering it and those receiving it. A German infantry squad under fire, and from M1-equipped American troops, would face fundamentally different tactical conditions than their training had prepared them for. Instead of hearing the measured crack-crack-crack of bolt-action rifles that indicated individual soldiers carefully aimed and fired and worked their bolts between shots, they would experience near-continuous semi-automatic fire from multiple directions simultaneously. The human instinct, conditioned by years of combat experience with the sounds of different weapons, would interpret this as machine gun fire. Soldiers under such fire would seek cover, would focus on suppression rather than maneuver, and would potentially overestimate the size of the force engaging them. Moreover, the M1's ease of operation reduced the training time and skill threshold required for effective marksmanship. A soldier with moderate ability could achieve respectable accuracy and high rates of fire with the Garand. The Kar-98K, while reliable and precise, required more extensive training to master the manual of arms, to work the bolt smoothly while maintaining sight picture, to reload quickly under stress, to manage the weapon's mechanical demands while simultaneously processing tactical information and making combat decisions. The M1 democratized firepower in a way that Klaus found simultaneously impressive from an engineering standpoint and deeply troubling from a strategic perspective. He included in his report a detailed section on manufacturing implications, drawing on his engineering education and his understanding of industrial production systems. The M1's design reflected American industrial philosophy, relatively simple components manufactured to consistent tolerances on high-speed production lines, assembled by workers who didn't require gunsmith-level expertise or extensive training. The rifle contained fewer than 70 major and minor parts. Many components were stampings or forgings produced rapidly once tooling was established. Final assembly and head spacing, the critical adjustment of barrel extension dimensions that ensured proper cartridge chamber support, could be accomplished by semi-skilled workers following clear procedures. This contrasted sharply with German production methods, which emphasized skilled craftsmanship and manual fitting. German weapons were excellent, often superior to Allied equivalents in raw performance, but they required more skilled labor to produce, more time per unit manufactured, more attention to detail throughout the production process. The Kar-98K was a masterpiece of precision. Each rifle was essentially handmade by skilled workers who fitted components together, adjusted tolerances, ensured proper function through expertise and experience. It was a system that produced outstanding weapons, but couldn't scale to match American production volume. Klaus requested intelligence estimates on American M1 production figures. The response arrived within days, in incomplete data, necessarily, since German intelligence had limited access to American industrial statistics. But captured documents, interrogations of American prisoners, aerial reconnaissance of American manufacturing facilities, and other sources suggested that M1 production had exceeded 1 million rifles by early 1944. Multiple factories were operating at full capacity. Springfield Armory in Massachusetts, Winchester Repeating Arms, and other facilities that had been retooled or built specifically for M1 manufacture. Production rates continued to accelerate. 1 million. Klaus typed the number into his report, then sat staring at it while his cigarette burned forgotten in the ashtray. Germany had produced approximately 14 million Kar-98K rifles throughout the entire war. A massive number, certainly, but accumulated over 6 years across multiple factories that had decades of experience manufacturing bolt-action rifles. The Americans had produced 1 million units of a far more complex weapon in roughly 3 years, and every indication suggested production was increasing rather than plateauing. The implications cascaded through Klaus's understanding of the war in ways he found increasingly difficult to contain within the boundaries of a weapons assessment report. If the Americans could produce M1 Garands at this scale while maintaining consistent quality, what else were they producing at comparable rates? He thought about the Sherman tanks that were beginning to appear in Italy and France in ever-increasing numbers. Individually, the Sherman was inferior to German heavy tanks like the Panther or Tiger, undergunned, under-armored, vulnerable in direct combat. But what if the Americans could produce 5 Shermans for every German heavy tank? What if they could replace battlefield losses faster than Germany could inflict them? What if quantity, supported by adequate quality, could overwhelm qualitative superiority? Klaus had been educated throughout his technical training and his years with the Heereswaffenamt that German engineering excellence would offset numerical disadvantages, quality over quantity, precision over mass production, superior tactics and superior weapons defeating larger but less capable forces. The Kar-98K embodied this philosophy perfectly. It was arguably the finest bolt-action military rifle ever manufactured, accurate and reliable and magnificently engineered. But the Americans hadn't chosen between quality and quantity. They'd achieved both, embodied in a semi-automatic rifle that was good enough to be very effective while being manufacturable in quantities measured in millions. Klaus completed his formal assessment report on September 1, 1944. The document ran to 23 pages of technical analysis, operational assessment, and strategic implications. He'd written it as objectively as possible, presenting data and evidence, without emotional commentary or editorializing beyond what was necessary to draw logical conclusions from the facts. But the conclusion itself was inescapable, stated clearly in the final paragraph of the operational assessment section. The M1 rifle represents a significant tactical advantage that German infantry forces have no immediate operational counter for. The Gewehr 43 semi-automatic rifle, while technically sound, is entering production in quantities insufficient to re-equip even a fraction of Wehrmacht infantry units. American forces possess a systematic firepower advantage at the individual soldier level that will manifest in every infantry engagement. He submitted the report through proper bureaucratic channels, signed, dated, with supporting documentation attached, including his detailed test data, photographs of the rifles evaluated, translations of captured American technical manuals, and comparative analysis with German and other Allied small arms. The report was acknowledged by his superiors at Kummersdorf, forwarded to the appropriate departments within the Heereswaffenamt headquarters in Berlin, and filed into whatever administrative system managed such intelligence assessments. Klaus received a brief acknowledgement letter confirming receipt, No questions followed. No requests for clarification or additional testing, no urgent meetings to discuss the implications. The report simply entered the system and disappeared into whatever processes governed German military intelligence evaluation. Life at Kummersdorf continued. Klaus tested other captured weapons as they arrived from various fronts. American bazookas, simple tube-launched anti-tank rockets that could be operated by infantry with minimal training, yet were effective enough to threaten German armor. British Sten submachine guns, crude stamped metal weapons that looked barely functional, but worked reliably and could be produced in enormous quantities. Soviet PPS submachine guns, with their distinctive drum magazines, distributed so widely that entire Soviet units carried nothing else. Each weapon told a story about its nation's industrial priorities and tactical doctrine. Each report, Klaus wrote, disappeared into the same administrative void, acknowledged but apparently without consequence. But Klaus kept returning to the M1 Garand. He'd fire it occasionally, ostensibly to verify some technical point for a supplemental report, or to demonstrate the weapon's characteristics to visiting officers from operational units. Really, he was trying to understand how German military intelligence had failed to recognize the significance of an entire nation equipping its infantry with semi-automatic rifles. The M1 had been officially adopted by the United States Army in January of 1936, 8 years before Klaus first test-fired it at Kummersdorf. 8 years during which American industry had ramped up production, refined manufacturing processes, trained workers, established supply chains, and distributed millions of these rifles to troops worldwide. How had German intelligence missed this? Or had they reported it, only to have the information dismissed as implausible American propaganda? Klaus had access to some pre-war intelligence assessments in the Kummersdorf archives. He spent several evenings reading through reports from the 1930s, looking for references to American small arms development. He found mentions of the M1's adoption, but the assessments dismissed it as an experimental program unlikely to achieve mass production. One report from 1937 confidently predicted that American attempts to equip infantry with semi-automatic rifles would fail due to the weapon's complexity and cost, forcing them to retain bolt-action rifles as their primary infantry arm. The assessment had been logical given what German intelligence understood about industrial capabilities and military economics. Semi-automatic rifles were expensive. They were mechanically complex. Every nation that had experimented with them had encountered problems, reliability issues, manufacturing difficulties, maintenance challenges in field conditions. The rational conclusion was that semi-automatic rifles would remain specialized weapons, issued selectively to troops who needed enhanced firepower in specific tactical situations. Germany itself had reached this conclusion after extensive development efforts. The Soviet Union had attempted semi-automatic rifle programs and largely abandoned them in favor of simpler weapons that could be produced in larger quantities. Even the Americans had struggled with their semi-automatic rifle development, trying multiple designs before settling on the Garand. But somehow the Americans had succeeded where others failed, or deemed the effort impractical. They'd designed a weapon that was reliable enough for universal issues. They'd developed manufacturing processes that could produce it in massive quantities while maintaining quality. They'd created training programs that taught millions of soldiers to use and maintain the weapon effectively. They'd established logistics systems that could distribute millions of rifles and billions of rounds of ammunition across global supply chains to forces fighting in Europe, the Pacific, North Africa, and elsewhere simultaneously. Klaus found himself conducting thought experiments, trying to model the industrial systems required to achieve what the Americans had achieved. The M1 Garand wasn't a simple weapon. Manufacturing the barrel alone required sophisticated machinery rifling equipment that could cut precise spiral grooves inside a steel tube, heat treatment facilities to harden the barrel properly, gauging equipment to verify dimensions within thousandths of an inch. The receiver had to be machined from forgings, with multiple operations required to create the complex internal surfaces that guided the bolt and contained the operating rod. The gas system components needed precise dimensions to function reliably. Every part required quality control, inspection, verification against specifications. Now multiply that across millions of rifles. Multiply it across multiple factories, each requiring the same specialized equipment, the same trained workforce, the same quality control systems. Multiply it by the ammunition production required billions of rounds per year, each cartridge manufactured to specifications that ensured reliable function in the semi-automatic action. Multiply it by the replacement parts that needed to be produced and distributed to maintain rifles in service worldwide. Multiply it by all the other weapons the Americans were producing simultaneously, artillery, tanks, aircraft, ships, all the equipment that modern warfare consumed in staggering quantities. The mathematics became overwhelming. Klaus had studied industrial engineering as part of his technical education. He understood production capacity calculations, manufacturing efficiency curves, economies of scale. What the Americans had achieved with the M1 Garand alone, just this one weapon system, represented industrial capability that exceeded Germany's entire small arms production across all weapon types. And the M1 was just one component of American military production. They were simultaneously manufacturing machine guns, submachine guns, pistols, mortars, artillery pieces, tanks, trucks, aircraft, ships, all while maintaining quality standards that matched or exceeded German manufacturing. In October of 1944, Klaus received another captured American weapon for evaluation, the M1 Carbine, a lighter semi-automatic rifle issued to support troops, vehicle crews, officers, and other soldiers who didn't serve in frontline infantry roles. It fired a less powerful cartridge than the M1 Garand, more comparable to a pistol round than a full-power rifle cartridge, but it maintained the same semi-automatic operating principle, providing rapid-fire capability to soldiers who in the German military would carry pistols, submachine guns, or no personal weapons at all. Klaus tested the M1 Carbine with the same thoroughness he'd applied to the Garand. The weapon was lighter, handier, less powerful, but still effective at infantry combat ranges under 300 meters. It was also clearly designed for mass production, even more so than the Garand, with extensive use of stamped metal components, simplified manufacturing processes, and minimal machining operations. The Carbine was, in many ways, a more impressive achievement than the Garand because it represented a completely new weapon system developed and fielded during wartime. The Americans had identified a need for a lightweight personal defense weapon more effective than a pistol, but lighter than a full rifle, designed a weapon to fill that need, ramped up production, and distributed millions of carbines to troops and worldwide, all within approximately 3 years. Klaus added a brief supplemental report to his original M1 Garand assessment. The tone was more direct than his earlier writing, perhaps because he no longer expected the report to change anything, or perhaps because the accumulated weight of evidence had eroded his caution about stating uncomfortable truths. The M1 Carbine extends American semi-automatic firepower to soldiers who do not serve in rifle infantry roles, he wrote. Truck drivers, radio operators, artillery crews, headquarters staff, medical personnel, and similar support troops carry weapons capable of semi-automatic fire at effective infantry combat ranges. This represents a fundamental difference in military doctrine from German practice, where such personnel typically carry pistols or no personal weapons. In practical terms, American supply columns or rear area installations can defend themselves with firepower comparable to German infantry units. This has significant implications for partisan warfare, infiltration tactics, and any military operations that encounter American support troops. He submitted this supplemental report through the same channels as his original assessment. It received the same cursory acknowledgement. No questions, no follow-up discussions. The system had absorbed his analysis and apparently done nothing with it, or at least nothing that Klaus was informed about. He was an engineer at a proving ground, responsible for technical evaluation of weapons. The strategic and tactical implications he identified were someone else's responsibility to act upon. His job was to provide accurate information. What military leadership did with that information was beyond his authority or his control. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The winter of 1944 to 1945 brought an acceleration of Germany's deteriorating military situation. The Western Allies advanced toward the German border. The Eastern Front collapsed inward as Soviet forces pushed through Poland toward East Prussia and Silesia. American and British bombers struck German cities and industrial facilities with increasing frequency and accuracy. The strategic situation that Klaus had tried not to think about while conducting his technical evaluations became impossible to ignore as the war approached German territory itself. Kummersdorf continued receiving captured weapons for evaluation, though the flow of material decreased as German forces were pushed back on all fronts. Klaus tested American Thompson submachine guns, British Bren light machine guns, more variants of Soviet weapons than he could catalogue effectively. He maintained his professional standards, conducting thorough assessments and writing detailed reports. But a certain futility had crept into the work. What was the point of evaluating enemy weapons when German industry couldn't respond to the intelligence these evaluations provided? What did it matter that Klaus could precisely document the tactical advantages of American semi-automatic rifles when German infantry would continue carrying Kar-98Ks until the war's end? Because no alternative existed. In January of 1945, Klaus received informal word through the Kummersdorf administrative network that his M1 Garand assessment had been read by senior officers in the Heereswaffenamt and forwarded to operational planning staff. Someone, somewhere in the military bureaucracy, had apparently found his analysis credible and concerning enough to circulate beyond the usual recipients of technical reports. Klaus felt a brief surge of validation his work had mattered and had been recognized as important. Then he felt nothing, because recognition without consequence was meaningless. German infantry weren't being re-equipped with semi-automatic rifles, production priorities hadn't shifted, tactical doctrine hadn't been modified to account for American firepower advantages. The report had been read, acknowledged as accurate, and filed away as interesting but not actionable information. In March of 1945, with Soviet artillery clearly audible in the distance even at Kummersdorf, Klaus received evacuation orders. The proving grounds were to be destroyed or abandoned before Soviet forces arrived. All sensitive documents were to be burned or removed. All weapons, test equipment, and research materials were to be destroyed, evacuated, or hidden to prevent them from being captured intact and providing intelligence to the enemy. Klaus spent 3 days feeding papers into incinerators, watching years of weapons evaluation reports curl into ash and smoke. He destroyed test records, manufacturing assessments, intelligence summaries, operational analyses, all the accumulated technical knowledge that Kummersdorf had generated throughout the war. But he kept his M1 Garand assessment. It was a violation of orders, technically. All documents were supposed to be destroyed unless specifically designated for evacuation. Klaus folded the 23-page report carefully, placed it in a waterproof document pouch, and buried it among his personal effects. He couldn't articulate exactly why he wanted to preserve it. Perhaps because it represented the moment when he'd understood, with absolute clarity, what Germany was facing. Perhaps because it documented truth that had been ignored but deserved to be remembered. Perhaps simply because destroying it felt like erasing evidence of his own professional competence, and he wanted something to survive that showed he'd understood, he'd reported accurately, he'd done his job even if the system hadn't responded appropriately. The evacuation from Kummersdorf was chaotic but ultimately successful. Klaus and most of the facility's personnel withdrew westward ahead of the Soviet advance, joining the vast flow of German military units and civilian refugees flooding toward what everyone hoped would be safety in the American or British occupation zones. The weapons that Klaus had tested, including the M1 Garands, were destroyed before the evacuation, broken apart and burned to prevent them from being captured intact. Klaus tried not to think about the irony of destroying American weapons to keep them from Soviets who were allied with the Americans. The logic of total war often produced such absurdities. Klaus surrendered to American forces in late April of 1945, part of a large group of Wehrmacht soldiers and Heereswaffenamt personnel who had retreated into Bavaria. The Americans processed them efficiently: identification, interrogation to assess potential war crimes or intelligence value, classification as standard prisoners or persons requiring further investigation. Klaus was forthcoming about his work at Kummersdorf. He'd been a weapons engineer, conducting technical evaluations of captured equipment. No combat service, no involvement in occupation administration or security operations, no party affiliations that would flag him for war crimes investigation. During his initial interrogation, conducted by an American officer with decent German language skills, Klaus mentioned his evaluation of the M1 Garand. The American officer showed immediate interest, asking detailed questions about Klaus's assessment, his testing procedures, and his conclusions. Klaus explained as clearly as he could the rifle was excellent, superior to the Kar-98K in every practical measure except perhaps long-range precision, which rarely mattered in infantry combat, representing a fundamental tactical advantage that American forces had possessed throughout the campaign in Western Europe. "Did your superiors act on your report?" the American officer asked. "It was acknowledged," Klaus replied. "I received confirmation that it had been read at senior levels, but no operational changes resulted from it, at least none that I was informed about." The American officer made notes, then asked Klaus if he'd be willing to write a summary of his findings for American technical intelligence. Klaus agreed. He had no reason to refuse, and some vague hope that cooperation might result in better treatment or earlier release. He spent several days in American custody writing an abbreviated version of his original assessment, working from memory since he'd left his archived copy buried in his personal effects during processing. The Americans seemed satisfied with his cooperation, classified him as a low-priority detainee, and moved him to a temporary holding facility to await whatever administrative decisions would determine his ultimate fate. During processing, an American sergeant casually slung his M1 Garand over his shoulder while checking Klaus's documents. The gesture was completely unremarkable to the sergeant, just shifting his rifle to free up his hands for paperwork. But Klaus found himself staring at the weapon, at how naturally and unconsciously the American soldier handled it. To this sergeant, the M1 wasn't sophisticated military technology or an example of industrial superiority. It was just his rifle, the standard equipment he'd been issued and trained with, as familiar and unremarkable as his boots or his helmet. The sergeant finished with Klaus's papers, picked up his rifle with the same casual familiarity, and moved on to process the next prisoner in line. Klaus was detained for several months in American custody before being released in late summer of 1945. The war had ended in May. Germany was occupied, divided into zones administered by the Americans, British, French, and Soviets. The nation Klaus had served lay in ruins, its cities bombed into rubble, its industrial capacity destroyed, its population scattered and traumatized. Klaus returned to what remained of his family's home in Berlin, found it partially destroyed by bombing, and began the grinding process of survival in a devastated city. He found work eventually, using his engineering skills to help with reconstruction efforts. Manufacturing firms needed technical expertise to rebuild destroyed facilities and retool for peacetime production. In 1947, Klaus secured a position with a company producing agricultural equipment, tractors, harvesters, implements for farming communities, trying to rebuild Germany's food production capacity. The work was honest and necessary, far removed from military weapons but utilizing the same engineering principles and manufacturing knowledge. Klaus never worked on military projects again. He'd seen enough of warfare and its consequences to last several lifetimes, but he kept his M1 Garand assessment, carefully preserved through the chaos of Germany's collapse and his personal displacement. He stored it with other personal documents, his engineering diploma, his employment records, family photographs that had survived the war. He never discussed it publicly, never wrote articles or gave interviews about his wartime work. When asked about his service, he'd mentioned that he'd been an engineer at a weapons testing facility, nothing more. The details seemed irrelevant to post-war life and uncomfortable to revisit. Sometimes, in quiet moments over the decades that followed, Klaus would take out the report and read through it. The technical language remained accurate, his measurements, his observations, his conclusions. The strategic assessment that had seemed so urgent in 1944 looked almost quaint in retrospect, given how the war had ended. Of course, Germany had lost. Of course, American industrial capacity had overwhelmed German military capabilities. The outcome had been inevitable once the United States fully mobilized its economy for war production. Klaus's report had simply documented one small piece of tables, that larger reality, one weapon system among thousands, one example of the industrial disparity that had ultimately determined the war's result. But what struck Klaus most when reading his old report was how clearly he'd understood the implications, even in August of 1944, and how little that understanding had mattered. He'd provided accurate intelligence to his superiors. He'd documented American capabilities precisely. He'd explained the tactical and strategic consequences in unambiguous language. The report had been read, acknowledged, even circulated to senior officers. And absolutely nothing had changed because the German military system couldn't respond to information that required fundamental changes in industrial capacity and tactical doctrine. Klaus had identified a problem that had no solution given Germany's material and economic situation in late 1944. Recognizing the problem didn't make it solvable. The M1 Garand remained in United States military service for nearly 2 decades after World War II ended. American forces carried it through the Korean War from 1950 to 1953. Early American advisors in Vietnam carried M1 rifles before the military transitioned to the M14 and eventually the M16. The weapon that Klaus had test-fired at Kummersdorf in August of 1944 equipped American infantry through multiple conflicts, proving its reliability and effectiveness across diverse environments and conditions. Over 4 million M1 rifles were produced during World War II alone, with production continuing into the 1950s for Korean War requirements. General George S. Patton, commanding American forces in Europe during World War II, famously called the M1 Garand the greatest battle implement ever devised. That assessment came from a commander who'd seen the weapon in action across multiple campaigns: North Africa, Sicily, France, Germany itself. Patton understood the tactical advantages the M1 provided to American infantry, how it enhanced individual soldier effectiveness, and amplified the firepower of rifle squads and platoons. His praise wasn't technical evaluation but battlefield observation. American soldiers equipped with M1 rifles consistently outperformed enemy forces, armed with bolt-action rifles in infantry engagements, all else being equal. Klaus Reinhardt had reached essentially the same conclusion from a very different perspective, test-firing the rifle at a German proving ground while his nation's military capacity crumbled around him. Two men, opposite sides of the war, arriving at similar assessments through different means. Patton saw the M1's effectiveness through tactical results, won firefights, captured objectives, enemy forces suppressed or destroyed. Klaus saw it through engineering analysis, rates of fire, mechanical reliability, industrial implications. Both understood that the weapon represented something more than just another rifle. It represented a transformation in infantry combat that gave American forces a systematic advantage at the most fundamental level of warfare. The irony that Klaus confronted at Kummersdorf wasn't simply about one weapon's superiority over another. The Kar-98K was an excellent rifle by any technical standard, accurate, reliable, well-manufactured. German infantry had fought effectively with it throughout the war. The weapon itself wasn't the problem. The problem was that the Americans had moved beyond the paradigm that rifles like the Kar-98K represented. They'd designed and fielded a weapon that embodied a different philosophy of infantry combat, one that assumed industrial capacity could provide every soldier with semi-automatic firepower rather than reserving such weapons for specialized troops. They'd built the industrial systems to manufacture millions of these rifles while maintaining consistent quality. They'd created logistics networks to distribute the weapons and billions of rounds of ammunition to forces worldwide. They'd trained millions of soldiers to use and maintain the rifles effectively. Germany had pursued excellence in individual weapons while accepting that resource constraints limited how widely such excellence could be distributed. The Americans had pursued adequate excellence weapons that were good enough to be very effective and distributed that adequacy universally through industrial mass production. It was the difference between equipping elite units with outstanding weapons and equipping every unit with good weapons. The Americans had chosen the latter approach and had the industrial capacity to execute it at continental scale. Klaus had understood this in August of 1944, standing at the Kummersdorf firing line with an M1 Garand in his hands, counting the seconds it took to fire 8 rounds and doing the mathematics on what that meant when multiplied across millions of American pursed soldiers. He'd written a detailed report explaining what he'd discovered and what it meant for German forces facing American infantry. That report had been filed, acknowledged, and ultimately ignored, not because German leadership was incompetent, but because the information described a problem that couldn't be solved through administrative action or industrial reallocation. By mid-1944, Germany's military situation had deteriorated beyond the point where weapons production changes could alter strategic outcomes. The story of Klaus Reinhardt and the M1 Garand reveals something fundamental about how modern warfare operates at the intersection of industrial capacity, tactical effectiveness, and strategic reality. Technical intelligence matters. Accurate assessment of enemy capabilities matters, but information alone doesn't determine outcomes. Klaus had provided his superiors with precise intelligence about American small arms superiority. They'd read it, understood it, and continued fighting with the weapons and systems they already possessed because no alternative existed. Understanding doesn't equal capacity to respond. Klaus lived until 1983, long enough to see Germany rebuild into an industrial democracy and NATO ally. Long enough to see his grandchildren grow up in a peaceful, prosperous Europe that bore little resemblance to the continent he'd known during the war years. Long enough to watch West Germany become one of the world's leading manufacturing economies, producing everything from automobiles to machine tools to consumer electronics, with the same engineering excellence that had characterized German industry before the war's devastation. He never spoke publicly about his wartime work at Kummersdorf. His family knew he'd been a military engineer, but Klaus deflected specific questions about what he'd done or what he'd learned. The details seemed irrelevant to post-war life. Germany had lost the war comprehensively, whatever. Technical evaluations Klaus had produced during his service had been footnotes to that larger reality. He documented one weapon system's superiority while working for a military that lacked the industrial capacity to respond to such documentation. He'd understood what was happening while being powerless to change it. That understanding had carried no particular meaning or consequence beyond confirming what the war's outcome had already demonstrated. When Klaus died in the winter of 1983, his children found the M1 Garand assessment while sorting through his personal papers. The yellowed pages, carefully preserved for nearly 40 years, seemed like artifacts from another era. His daughter, an attorney with no military background, read through the technical language and operational assessments with incomprehension. His son, an engineer like his father, understood enough to recognize the document's significance. This was intelligence that German military leadership had possessed in 1944, accurate assessment of American capabilities provided by a competent analyst working at a premier testing facility. They donated the document to a military history archive in Munich that specialized in Wehrmacht operational records and technical intelligence materials. The archive staff catalogued it carefully, added it to their collection of similar documents that painted a picture of Germany's military situation in the war's final year. Researchers occasionally reference it in studies of German weapons evaluation procedures or assessments of World War II small arms effectiveness. It's a footnote, really one engineer's detailed report on one weapon system, interesting to specialists but not historically significant beyond illustrating that German technical intelligence understood American capabilities, even when that understanding couldn't change strategic outcomes. The M1 Garand itself became a collector's item in the decades after World War I, prized by firearms enthusiasts and military historians. The rifles are mechanically interesting, historically significant, and still functional many decades after their manufacture. Klaus would have appreciated that longevity, the evidence that his technical assessment of the weapon's quality and reliability had been accurate. The M1s that survived military service continue working, still capable of the performance characteristics Klaus had documented at Kummersdorf in August of 1944. But the larger lesson that Klaus's experience illustrates transcends the specific weapon or the specific war. Military organizations collect intelligence constantly, evaluate enemy capabilities continuously, produce assessments and reports and analyses that flow up through bureaucratic channels to inform decision-makers. Most of this intelligence is accurate. Most analysts do their jobs competently, but intelligence is only useful if organizational systems can respond appropriately to what the intelligence reveals. Klaus had identified a significant tactical problem facing German forces. American infantry possessed superior individual firepower through universal distribution of semi-automatic rifles. That problem was real, significant, and essentially unsolvable given Germany's industrial and strategic situation in mid-1944. Understanding a problem doesn't make it solvable. Documenting a problem doesn't create solutions. Klaus had done his job as a weapons evaluator perfectly. He'd tested captured equipment thoroughly, analyzed its capabilities accurately, and reported his findings clearly. The system had absorbed his report and continued functioning exactly as it had before, because the information required responses that weren't available. German industry couldn't produce millions of semi-automatic rifles. German logistics couldn't distribute them to forces worldwide, even if production capacity existed. German military doctrine had been built around different assumptions and couldn't be rapidly transformed mid-war to accommodate new weapons, even if those weapons became available. So German infantry continued carrying Kar 98K bolt-action rifles into combat against American forces equipped with M1 Garands, not because German military leadership ignored intelligence about American capabilities, but because no practical alternative existed. Klaus's report had been accurate, thorough, and ultimately irrelevant to operational decisions because those decisions were constrained by factors beyond any individual report's influence. The war would be decided by industrial capacity, strategic resources, and the accumulated consequences of years of combat attrition. One weapon system's superiority mattered tactically, but couldn't determine strategic outcomes. That's what Klaus understood in those quiet moments reading through his old assessment report, decades after the war had ended. He'd documented the truth accurately. The truth simply hadn't mattered enough to change anything, arriving too late in a conflict already determined by larger forces. Sometimes being right isn't enough. Sometimes understanding comes without the power to act on that understanding. Sometimes all you can do is document what you've learned and hope someone, sometime, finds value in the documentation. The M1 Garand was, as Patton declared, perhaps the greatest battle implement ever devised, not because it was perfect, but because it was excellent enough and produced in quantities that ensured American infantry entered every engagement with a fundamental firepower advantage over enemies equipped with bolt-action rifles. Klaus Reinhardt had recognized this truth while test-firing a captured rifle at Kummersdorf in the late summer of 1944. That recognition didn't change the war's outcome. It didn't save German soldiers from facing American firepower superiority. It didn't alter industrial realities or strategic calculations. It simply meant one German engineer understood, with crystalline precision, what his nation confronted on the battlefields of Europe. Sometimes understanding comes too late to matter operationally, but early enough to be documented for history. Klaus's assessment survives in a Munich archive, available to researchers who want to understand how German technical intelligence evaluated American capabilities in World War II's final year. It's a small contribution to historical knowledge, a footnote in the vast literature on the war and its weapons, but it represents something important about how wars are actually fought and decided, not just through battles and campaigns and strategic decisions, but through industrial capacity, technological development, and the countless small advantages that accumulate into decisive superiority. Klaus Reinhardt test-fired an M1 Garand on an August morning in 1944 and immediately understood its implications. He wrote a comprehensive report explaining those implications to his superiors. The report was read, acknowledged, filed, and forgotten. German infantry continued carrying bolt-action rifles until the war's end 9 months later. The system had worked exactly as designed. Intelligence was collected, evaluated, and reported. The system had also failed exactly as constrained by reality. Information that couldn't be acted upon effectively didn't change outcomes regardless of how accurate it was. That's the fundamental irony Klaus confronted at Kummersdorf, the truth that would follow him through 4 decades of post-war life. Being right isn't always enough. Understanding doesn't guarantee influence. Intelligence matters only when systems can respond appropriately to what intelligence reveals. Klaus had documented American industrial and tactical superiority in small arms, proven it through rigorous testing, explained it clearly in written reports, and none of it had mattered because the war had already been decided by forces larger than any individual weapon assessment could address. The distinctive metallic ping of an empty M1 Garand en-bloc clip, ejecting that sound Klaus first heard on the Kummersdorf range in August 1944, became one of World War II's most recognizable auditory signatures. American veterans remembered it as the sound of their rifle running dry in combat. Enemy soldiers remembered it as the brief moment of vulnerability when an American rifleman's weapon was empty, though that vulnerability lasted only seconds as the soldier reloaded. Military historians recognize it as an acoustic indicator of the semi-automatic rifle that redefined infantry warfare for the modern era. Klaus Reinhardt remembered it as the sound that accompanied his realization that Germany was fighting a war it couldn't win through tactical excellence or weapons quality alone. That understanding came in 6 seconds of sustained fire, in the mathematics of firepower, multiplication, in the industrial implications of millions of rifles manufactured to consistent standards. It came too late to matter strategically, but early enough to be documented. One engineer's assessment of American capability preserved for history, even if it couldn't change the war's outcome. Sometimes the most important intelligence isn't what changes decisions, but what records truth for posterity. Klaus's M1 Garand assessment did that. It documented what one competent German engineer understood about American military-industrial capability in 1944, what he reported to his superiors, and how little that understanding influenced operational reality. It's a small story about one weapon and one man's evaluation of that weapon. But it captures something essential about how modern warfare operates, not through individual genius or tactical brilliance, but through industrial systems that can design, produce, and distribute adequate excellence at continental scale, overwhelming qualitative advantages through quantitative superiority backed by engineering competence. That was the lesson of the M1 Garand, the truth Klaus learned at Kummersdorf and carried with him for 40 years. American industry had achieved something that seemed impossible by German standards: mass production of a complex weapon system without sacrificing quality or reliability. They'd equipped millions of soldiers with semi-automatic rifles, providing every infantry rifleman with firepower that German doctrine reserved for specialized troops or machine gunners. They'd done this not through superior individual engineering, but through superior industrial systems that could scale excellence across millions of units. Quality and quantity weren't opposites in American production philosophy. They were complementary achievements, both necessary for decisive military superiority in industrialized warfare. Klaus understood this. He documented it carefully, he reported it through proper channels, and German soldiers continued carrying bolt-action rifles into combat until Germany surrendered unconditionally in May of 1945. Understanding wasn't enough. Documentation wasn't enough. Intelligence that couldn't be acted upon effectively might as well not exist, except as a historical record for future generations trying to understand how wars are actually fought and why they end as they do. The M1 Garand wasn't the reason Germany lost World War II. No single weapon system determined such outcomes. But it was emblematic of the industrial and technological disparity that made German defeat inevitable once the United States fully committed to the war effort. Klaus had recognized that disparity through testing one rifle. His report extrapolated from that rifle to larger conclusions about American capability. Those conclusions were accurate. They were also irrelevant to operational decisions in late 1944 because the information arrived when Germany's strategic situation had deteriorated beyond the point where weapons assessments could influence outcomes. That's what Klaus thought about sometimes in his later years, reading through his old report and remembering that morning at Kummersdorf when he'd first fired the M1 Garand. He'd been right. His analysis had been accurate, his conclusions had been sound, and none of it had mattered because the war was already decided by forces larger than any individual technical assessment could address. Being right isn't always enough. Sometimes all you can do is document the truth and hope someone finds value in that documentation, even if the truth arrives too late to change anything. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.